Hi everyone. In this video I am going to introduce a concept called a logic circuit called decoder. Decoder is the opposite action of the encoder, what we have seen in the previous 4 to 5 videos. Decoder is nothing but it is a logic circuit. It is a logic circuit that has n inputs and 2 power n outputs. N inputs and 2 power n outputs. That means size of a decoder is n by 2 power n. The size of a decoder is n by 2 power n. Don't confuse. Decoder and encoder both are opposite purposes. Decoder and encoder both are for the opposite purposes. That means what is the size of the encoder? Size of encoder is 2 power n by n. 2 power n by n. That means out of in the encoding operation, out for 2 power n number of bits, we will be using only n number of bits in the communication. Suppose, as I said earlier, this particular decoder and encoder operations are commonly preferred in communication of digital data. Decoder used in communication of digit formats, nothing but digital communications. Suppose here we have a medium. Medium is always a wireless medium, or it may be wired medium depending upon the uses. Here we are having encoder. Encoder is always used at the transmitting side, and decoder is used at the receiving side because it is opposite action of the encoder. Okay, now what I said, encoder is having a size 2 power n by n. 2 power n by n. So what is the input size? Input is 2 power n. Okay, we are having, let us consider n is equal to 3. Let us, for example, n is equal to 3. N equal to 3 means 2 power n is equal to 8. 2 power 8 is equal to 2 power 3 is equal to 8. 2 power 3 is equal to 8. That means here the input is having 8 bits of information. This 8 bits of information is converted down to 3 bits. See here the input bits are 8 bits, and whereas after passing through the encoder we will be having the number of bits as only 3. This is what the encoding operation. So after encoding operation we will be having very less number of bits compared to the original input bits. Okay, that means these 3 bits are having the information which the 8 bits carries. Okay, now these 3 bits passing through the medium, and after medium we are having 3 bits. And what is the size of the decoder? Decoder size is n by 2 power n. So what is the number of bits we are giving? 3 means 2 power 3 is the output. So total again 8 bits of information we are receiving at the receiver. Okay, here we are having the receiver and here we are having the transmitter. So transmitted bits are 8 bits and again the received bits are 8 bits. So in this way the purpose of decoders and encoders are used in the communications where the encoder and decoder takes the opposite operations of the each other. So encoder is used to compress the data and decoder is used to decompress the data. Okay, so from this what we need to understand is encoder is used to compress the data and decoder is used to decompress the data. Okay, so encoder is used to compress the data. Compress the data. Decoder is used to decompress the data. Decoder is used to decompress the data. Decompression is nothing but we are elaborating the data again. Okay, compression is nothing but we are reducing the information. Okay, this is the purpose of encoder and decoder. Okay, this is about decoder. That means decoder, if you draw a block diagram of a decoder, decoder has n number of inputs and we are having 2 power n number of outputs. 2 power n number of outputs. This is decoder block diagram. Okay, now let us see example 2 to 4 decoder, also known as 2 line to 4 line decoder. 2 line to 4 line decoder, also known as 2 to 4 decoder. Okay, decoder, encoder and multiplexer, demultiplexer, these are represented like this: 2 by 4, 2 to 4. Okay, 2 by 4 decoder, generally 2 by 4 decoder, 4 by 1 multiplexer. Okay, like that we will use. Okay, so 2 by 4 decoder, 2 inputs are there and 4 outputs are there. Okay, consider an enable pin E along with 2 inputs, So what is the purpose of enable pin? Here the decoder, encoder and multiplexer, all these are integrated circuits. Generally they are available in the form of integrated circuit. So for the integrated circuit we always have an enable pin to activate the IC, to activate the integrated circuit. That's why enable pin came into existence. If enable pin is there, that we will use. Otherwise, if enable pin is not there, then the remaining normal operation will be going on. Okay, so enable pin we are taking along with the 2 inputs what the decoder has, and now 4 outputs are there. 4 outputs we are taking it as D0, D1, D2, D3, 4 outputs. Okay, now enable is equal to 1. Here we are taking active low. Consider active low configuration. That means all are in the 0 mode. 0 means active high here. 0 means active high. 1 means active low. That's why when enable is disabled, see, E is equal to 1. Actually 1 means active pin, but here 1 is considered as active low because it is in active low configuration. Okay, so enable is equal to 1 means here the chip is disabled. As the chip is disabled, whatever the input we are giving, it will not respond and simply all outputs are active low. Here chip is disabled condition. Okay, now activate the integrated circuit, activate the decoder. So when enable is equal to 0, chip is activated or decoder is activated. Now the control goes on to the inputs. Whatever the input we are considering, the corresponding bit will be highlighted and all other are deactivated. Again 0, 0, 1. Enable equal to 0 means chip is activated, and A equal to 0, B equal to 1 means output is D1. So D1 is activated and remaining are zeros. Remaining are ones. 1 means active low here. Again for 0, 1, 0, 0, 1, 1. So here it is 1, 1. 2 means D2 is activated and 1, 1, 1, D3 is activated. This is the truth table of a 2 line 4 line decoder, 2 to 4 line decoder. Two to four line decoder. Okay, so how to write the expression for D naught here? D naught is activated when A is equal to 0, B is equal to 0 and E is also equal to 0. That means all three are complemented form. So D naught is equal to E bar, A bar, B bar. D naught is equal to E bar, A bar, B bar. And D1 is nothing but E bar, A bar, B. E bar, A bar, B. All these are in active low mode. So that's why all should be implemented with NAND gate. Okay. So as the output and inputs are in active low configuration, so the expression for D naught is equal to E plus A plus B. E plus A plus B. So we can write it as E A B whole bar. E bar here also it is E bar A bar whole bar. Okay. So E bar A bar B bar, and similarly D1 is equal to what is the output? A bar B, and it is E bar whole bar. D3 is equal to D0, D1, D2. D2 is equal to A B bar and E bar. E always bar only, because it should be activated when the IC is activated when E is under active low. And similarly D3 is equal to AB E bar whole bar. Okay, see here 0 0 0 1 1 0 1 1. Okay, A bar B bar means 0 0, A bar B means 0 1, A B bar 1 0, A B 1 1. Okay, this logic circuit can be implemented. Therefore the logic circuit can be implemented for 2 to 4 decoder is shown here. Okay, so we are taking A bar B B bar, A in true form, A in complement form, B in true form, B in complement form, and similarly E in true form. E true form nowhere it is used, and E complement form only. Okay, so for D naught we need one NAND gate, What is the NAND gate output? A bar, B bar and E bar. It is D0. And D1, D2, D3. D1, D2, D3. So A bar B, A bar B, and it is E bar only. And again A B bar, A B bar and E bar. And here AB, A B and it is E bar. Okay, so this is a simple logic circuit that converts 2 bits of information into 4 bits of information. That means 2 line to 4 line decoder. Thank you.